Hey gang, we're ME13. We had the ligature-resistant linear drain project, sponsored by Zurn Industries.
If you don't know who Zurn is a trusted distributor of plumbing products and water fixtures. Most likely, you have seen a Zurn product because they are everywhere. Bathrooms, showers, parking lots, everywhere you're going to see a Zurn product.
Alright gang, this is an example of a non-ligature-resistant linear drain. As you can see, the drain channel is linear. It makes a line here. Ways that you can form a ligature, some examples are looping and wedging. This non-ligature resistant drain is very much prone to looping. As you can see here, you could insert maybe a shoelace, maybe a headphone cord right into this hole, and if you have any sort of stick or rod or other piece like a plastic butter knife, for example, you could reach in and grab it and pull it out and then tie it, and now you have a ligature. Alright gang, this is an example of a ligature resistant point drain. This design is fully developed and ready for sale. If you look into the top here, there's no locations where a ligature could directly be formed via looping or wedging. Alright gang, you might be wondering what a ligature is. A ligature is anything that binds or connects, such as a rope or a shoelace that you tie around and can be used as an anchor point. Cut to the example.
So you may be wondering what our design looks like and how it compares to the linear drain. So here's what our design ended up looking like. As you can see, we substituted the rows of channels for two small narrow channels so that it's hard to wedge stuff into, and looping is very difficult, although we cannot show you the cross section.
Here's a time-lapse of some ligature resistance testing which we conducted. You can see some common materials which we mentioned prior, such as that shoelace trying to knot it up and get it to wedge in, or some floss trying to get that to loop around under. None of this was all too successful as we expected.
Alright, what's up chat? So in order to make sure that our design was structurally sound and could withstand a number of cycles, we used finite element analysis. As our design was made with 304 stainless steel, we tested a 2-inch load patch on the design to ensure that it would not exceed the yield stress. And with our simulation, we found that it did not. And using an SDM diagram, we found that the design far exceeded the minimum 10,000 cycle fatigue life.
An important aspect of drains is that it actually drains water. Our goal for our drain was to hit 7 gallons per minute, and we vastly exceeded that, hitting upwards of 28 gallons per minute. We did CFD to confirm this, and additionally, we did in-person testing, shown here.
It's not hitting.